So let's refresh those formulas that we did yesterday. Converting from rectangular to polar. Remember, rectangular means I have an XY coordinate. To polar means I'm looking for a radius and an angle. And remember how that works. As opposed to moving left and right and then up or down in very squared off movements, we move out and around. And that's where our angle brings us. So that's how we graph using a polar as opposed to a rectangular. But the formula to convert is r is found by taking the square root of x squared plus y squared, and that was just based off of the Pythagorean theorem, and that's what we talked about in our notes yesterday. And then theta is the tangent inverse of y over x, and so you'll have to put the things together and do those conversions. Sometimes you're going to have to think a little bit because things are going to come up as maybe undefined or in a simplified form, and you're going to have to go back to the things that we've talked about in our previous lessons, the families that we've looked at, to kind of talk your way through it. But keep in mind, we are very restricted. I said it before. Your answers are going to be pi over 3, pi over 4, pi over 6, or one of those family members. 0 pi, pi over 2, 3 pi over 2. We're very limited. All right? So let's do a conversion with this next one. Before we do the conversion, does anybody think that they can convert this one in their head without doing any math? I've got a couple of you that think you can. Okay? Jack, go ahead. What do you think it is?
2 and 3 pi over 2.
2 and 3 pi over 2. Moss, would you agree with him or disagree with him? Agree. And why do you guys think that?
The square root's kind of easy to figure out.
Mm-hmm.
It's positive, negative, and it's like 0 over 2, so it has to be.
Yeah, it's like that position that was down here. That's the point where it's 0 some y value. And we used, in here, they gave us -2. That means it's too long and it stopped in that position. But again, remember, if you can't look at it and figure it out, then we can go ahead and do the math. So r would be the square root of 0 squared plus -2 squared. So r is 0 plus 4, square root of that. So r is the square root of 4. Remember, yesterday we said that we are going to restrict it to only the positive answers. I'm going to talk to you today about what if we have a negative radius, because you can have a negative radius. But that was us doing the math for that. And then when I'm finding theta, remember theta is the tangent inverse of y over x, so that's -2 over 0. That means I need to figure out when the tangent is undefined, because that would be 0 in the denominator. And again, the tangent is undefined, like I said, when I have something over 0. So that means I need to look to find where the cosine is 0. And the cosine is 0 at pi over 2 and -3 pi and 3 pi over 2. And so we're going to choose the position that this original point is in. So we pick the bottom one, 3 pi over 2, not the pi over 2 one. I'm going to most times come up with potentially 2 answers, bless you, that I'll work with. And I have to pick the one that's in the right position. It's all about location. It's always been about location. Okay, so next. This one's a little trickier. Does anybody think they know this one without doing any math? Okay? 4 and 4 pi over 3. So you're suggesting that the radius is 4 and that this is the pi over 3 family in the third quadrant. So I'm going to write that down. That's what we got. Does anybody agree? Yeah? Ethan, why? You did the math in your head. Okay. How do we get pi over 3 family? What's the kind of dead giveaway? Yeah.
The square root of 3 is the y position.
Yeah, the square root of 3 is in the y position, and remember that the pi over 3 family is 1/2 square root of 3 over 2. So that square root of 3 is in there. We just multiplied it by something. The 4 is a little bit more difficult, but if you work with the half, you can kind of figure that one out pretty quickly. Is that what you did? Worked off the half. What would I multiply a half by to get 2? But again, if I need to do the math, which is no problem, I just plug it in, -2 squared plus -2 times the square root of 3 squared. This is 4 plus, remember this is -2 squared, 4, times the square root of 3 squared, 3. 4 times 3 is 12, the square root of 16, and the 4 that Kendall got right from the beginning. Okay, so then we go and do our tangent inverse of -2 over the square root of 3 over -2. So that's the tangent inverse of the square root of 3. Some of you remember already that that is the pi over 3 family. That happens when we put the square root of 3 over 2 over 1/2. This is the square root of 3 over 2 over 1/2. That is when the sine is the square root of 3 over 2 and the cosine is a half, reduces down. We know that's the pi over 3 family. And it is pi over 3, and it's also positive in the third quadrant, so that's 4 pi over 3. Why did Kendall pick the third quadrant? Trish?
There's 2 negatives.
Because these are both negative, right? Yeah, because this point is a third quadrant point, so that's how we pick our angle, okay? How do you guys feel about these? Rectangular to polar. Okay-ish? Not too bad. Okay, so now we're going to step it up a notch. Now we want to convert from polar to rectangular, so we're going to go back the other way. So remember, polar means I have r comma theta, and I'm going to rectangular, which is x comma y. And so I'm going to draw a right triangle again, where theta is the angle that I'm looking at. I could like superimpose this onto a graph. I'm going to do it kind of in yellow underneath. Okay, so here's my circular motion that I'm moving. I'm moving out x and up y to get that position, x comma y, out x, up y, or I'm moving out r and then opening up theta. So if I'm graphing in rectangular, I move out x, up or down y. In this case, I'm in the first quadrant. If I'm doing polar, I move out a radius and then open up an angle. So if I know r and theta, how can I find x and y? Well, I'll do a little SOHCAHTOA. It turns out that the sine of theta is equivalent to the opposite over the hypotenuse. If I solve for y, that means I will multiply the r out. Then r sine theta will give me y. I can do the same thing for x, but to solve x, that's in the adjacent position. The cosine of theta is x over r. Solve for x. R cosine theta will give me my x coordinate. So when I am converting to a polar or to a rectangular coordinate from polar, it goes like this. R cosine theta is my x position. r sine theta is my y position. And that's it. Like I said, I think it's easier mathematically to do this conversion. It's more difficult mathematically to do the other conversion, but if you look for some shortcuts and tricks, it's not so bad. So if I'm working on problem number 3, this is polar. I know it's polar for 2 reasons, because they said each pair of polar coordinates is what I'm converting. And I also am pretty sure because I have an angle in that position. But if you're not sure if it's a polar or rectangular, just read the directions. This one is convert the polar to rectangular, so I'm going to take this. I have r and I have theta. And my x is found by taking r times the cosine of theta. In this case, x is 2 times the cosine of pi over 3. Cosine of pi over 3 is 1/2. So x is 1. Y is r sine theta. So y is 2 times the sine of pi over 3, which is 2 times the square root of 3 over 2, which is the square root of 3. So how do I write this point? X, comma, y, and I'm done. The nice thing about when you solve when you convert polar to rectangular is it will always take care of the signs for you. You don't have to think about, oh, what quadrant am I in? Which angle am I going to use? The angle will determine the quadrant automatically. So I know my answer is going to be a 4th quadrant answer because 11 pi over 6 opens up to the 4th quadrant. So when I plug my values in, it is x equals 3 cosine 11 pi over 6. X is 3 times cosine of 11 pi over 6 is positive square root of 3 over 2. So x is 3 times the square root of 3 over 2. Not a pretty answer, but we don't judge. I'll take it. I'm fine with it. That's my x. So my x coordinate is 3 times the square root of 3 over 2. Y is 3 sine 11 pi over 6. So y is 3 times negative 1/2 because the sign is negative in the 4th quadrant. So y is negative 3/2. Negative 3/2 is my y coordinate. Put that in rectangular coordinate form, x comma y, and then I am done with that part. Please try 5 and 6. So up next, plotting the point. I've talked about it now. We're going to put it to action. You're going to do this yourself. Remember, when you plot a polar coordinate, and if you're not sure if it's polar or not, just look at what the directions say. When you plot a polar coordinate, you go out your radius and open your angle. So in this first one, if my radius is 3 and my angle is 0, that means I go out to 3 and I don't open up at all, and I just put that point right there. Done. If I have a negative angle, just like any other time we have done this, it means it moves backwards. So for number 8, that means I move out 2 and then 1.5 pi around, backwards. So out 2, 1.5 pi around backwards, and that puts me in that upper position. Our movement will be just like it was when we were plotting those, trying to find the quadrant that we were in. Our movement will be the same. On occasion, they might give us an angle that is not a family member or doesn't look familiar to us, like in problem number 4. And so, approximate. It turns out that the graphs on this thing that we use are broken down into 12ths. So each line, even though it's not labeled, this is pi over 12, pi over 6, which is 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12. Do you get that, how I'm counting there? Bless you. So this means move out 4, and then I'm going to change this to a mixed number again, just like we did when we were trying to graph them. This is 1 7/12 pi. So I go out 4, and this is 1 pi. Move my fingers, sorry. 1 pi and 7/12 more. So this is 1, 2, 3, 4, 5, 6/12, 7/12 more. There's my point. If the grid is less clear in its breakdown, just do your best to approximate it. The other thing that's going to happen is we're going to have a negative radius, and I talked about that. It's not unheard of. Up to this point, we have always only used positive radii. But a negative radius kind of works in a similar fashion to a negative angle. It means I move the other way. So positive 3, I would move out right, 3. But negative 3, I would move to the left, 3. So my first movement is to the left. I move to the left 3, 1, 2, 3. And then I move backwards 1 1/4 pi. So from negative 3, I'm going to move backwards 1 1/4 pi. Keeping in mind about where a fourth is. So I started by moving left 3, backwards 1 1/4 pi. The thing with polar coordinates is there can be infinitely many coordinates that will land in the exact same spot. It just depends on the size of the angle. And so we're going to go ahead and write other coordinates for a given point. So this one is 2 13/12. What I like to do is get myself into that position. So plot that point. So this is right to 1 1/12 pi over. So right to 1 pi plus 1/12 more. The breakdown here, every one of those lines is a 12th. So 1 1/12 more. That is my position. What I like to do when I'm writing 3 other points is I just look at that and say, okay, how could I get there with a negative angle? Well, I'd move out 2 and I'd have to move back. How much am I moving back? Well, this is 1 12, 2 12, 3 12, 4 12, 5 12, 6, 7, 8, 9, 10, 11. Or you could think of it as I'm 1/12 shy of pi. So one other option would be right 2, backward 11 pi over 12. That's one option. Now, that's just one option. There are infinitely many ways that we could write this. So even if you write one answer, it might not match the answer that the people next to you have. But this is my suggestion. I start by trying to get there backwards. Then I say, what if I moved a negative radius? How could I get to that exact same point? Well, I have 2 different ways. I could move forward and I could move backward. Austin has a thought. You moved backwards. How many?
112.
Actually, you moved forward, because forward is that direction. So this would be negative, and then it would be forward pi over 12. That's 1 pi over 12. Great. Excellent job. Okay? So I have a positive radius, a positive angle, a positive radius, a negative angle, a negative radius, a positive angle. Let's do a negative one. So I'm going to move backwards 2. How far would I have to move in the backward direction to get all the way over there? What is it? Negative 23 pi over 12. Nice job. How'd you guys do that math so quick? Yeah, it's just shy of going 2 full pi around. It's 1/12 shy of that, so I can just do 2 pi, convert it into 12ths. That'd be 24 pi over 12. Subtract the 1 pi to get back to where I need to go. Great. Okay? How do you guys feel about this? Okay, so let's do our next one. Start by visualizing where it is, and then talk yourself through it. So this is right 3 around pi over 3. That's the first one. I want to get there with a negative angle. So I would move right 3 and backwards how much? We're at, what did you do, 21 pi over 12?
No, just 20.
20 pi over 12? Can you reduce that?
Yeah.
That would be divide by 4 divided by 5 pi over 3?
Yeah.
Yeah. Okay. Then I want to do 2 with negative radii, 1 with a positive angle, 1 with a negative angle. So if I move backwards 3, how far would I have to move around in the positive direction to get here? I just usually think about I'm in the pi over 3 family, and I'm moving. My first pi over 3 family would be in the 3rd quadrant. My second pi over 3 would be in the 4th quadrant. My third pi over 3 would be at the axis. My 4th pi over 3, or I kind of flip it around. How do I get through 3 quadrants? That would be 4 pi over 3. So this is forward 4 pi over 3. You're just going to have to kind of move your brain around a little bit. If I move left 3, how can I get here moving backwards? Great. Again, all about movement. And this is not restricted to this. In fact, there are other ways that you could do this. There are some people that are just like, well, I know I can get here by adding 2 pi.
I was ready for you to finish.
No, that's okay. Go ahead. And so they take their angle and they just add 2 pi to that angle, and then they add 2 pi more, and then they add 2 pi more, and they have 3 different angles just by adding 2 pi. Totally acceptable, a different way to do it. I always like to get variety. It helps me feel like I'm moving around the circle a little bit, getting practice with my movements. Just like solutions to equations, there is more than one solution that we just saw here when we were graphing. And so I want to be able to write all solutions. And so I'm going to write 2 different all solution sets. One set will be the positive radius, and the other set will be with a negative radius, okay? And so the first thing that I want to do when I want to find all solutions is I'll plot this point. This is 2 pi over 6. I'm going to write a negative radius equation for that. I want a positive angle. So negative radius would be back 2, forward 1 pi plus an additional pi. So this would be 7 pi over 6. All right? That's 1 positive, 1 negative radius. Now I want to get all solutions. So the first solution would be 2 comma pi over 6 plus 2 pi k. Remember that? And the second one would be negative 2 comma 7 pi over 6 plus 2 pi k. What is k? K is an integer. Now I've just covered every possible angle with a positive radius, every possible angle with a negative radius. Yeah. How what? Because integers are positive and negative numbers. So adding 2 pi k, if k is negative 1, would be subtracting 2 pi. If k is negative 2, be subtracting 4 pi. So it'll cover all. That's why we use integers as that value. And that's a very good question to ask. They're all covered. And again, if you chose different angles here, like chose to put a negative angle with your negative radius, you would still add the 2 pi k. You would still cover everything. But like I said, I like 1 positive, 1 negative. Okay, so let's do the last one, or the next one. And then I'm going to let you guys try too. So my first point is 3, 4 pi over 3. So I go 3, and then 4 pi over 3, put my point in there. Okay. 1, 2, oops, I went too, ignore that one. I went too far out. Okay. So 3, 4 pi over 3. I'm going to get my negative radius. If I moved left, 1, 2, 3, how do I get here? Positive move. Yep. What's wrong? So 1, 2, oh, no, okay. This one's wrong. Sorry. Okay. I didn't mean to. All of you guys are looking at me like, what are you doing? You're making me nervous. Pi over
3.
pi over 3. Your families won't change, so it'll always have the same denominator that you started with. And if I just think about, again, this is a pi over 3 family, I'm only moving into one quadrant, so it would be the first quadrant answer. Okay, so let's get those as all. This is 3, 4 pi over 3 plus 2 pi k. Negative 3 pi over 3 plus 2 pi k. First point, second point, k is an integer. Okay, now I want you to give the last two a try. Plot your point, come up with a negative value. Keep in mind, there is not one exact. Have to have the exact same answer. There are other ways that you could do it. If you chose, especially I think this one's a really good example of, it's probably easier to get to this point if I move left to go backwards pi over 6, and if you use negative pi over 6 instead of 11 pi over 6, you're fine. Just a different way of writing the same thing. Does anybody have any questions on these? Kind of moving around the graph? Tomorrow, we're actually going to graph polar equations. And so if you take a sneak peek at the next sheet, they're sort of fun because they make a lot of interesting shapes that we have. We'll be graphing little flowers, things like that, okay? So that is our tomorrow. needing to know how to move around and manipulate a polar or polar point is going to be very helpful for tomorrow's stuff. But homework is 6-2 evens or odds.